All right, so we're going to go through a whole test about a population proportion. So back to our free throw shooter example. First of all, we have to check our conditions. So we have a null hypothesis that he's an 80% free throw shooter, and an alternate hypothesis that he's less than that. And then we did our sample statistic, and we got our 64%, right? So your conditions for checking before you do a significance test. So you have to check, is it random? And you should write this down. So the problem's going to have to tell you that it came from a well-designed random sample or randomized experiment. Okay, then you have to check 10% when you're sampling without replacement, which is n is less than or equal to a tenth of n. This gives you independence, right? As long as you have a big enough sample. And then large counts, you're going to check n times p and n times 1 minus p are both greater than or equal to 10. The only difference in this is our p is coming from the null hypothesis, all right? This comes from the null. So in this problem, our null hypothesis is 80%. That's what you're going to use for p. And that gives us large counts, which means we have normality and can use Normalcdf in our calculations. All right, we're also going to calculate a test statistic, and so this measures how far a sample statistic diverges from what we would expect if the null was true. So our test statistic is always the statistic minus the parameter divided by the standard deviation. So this, when we were doing means, looked like this. Our statistic, whatever our x was, minus the mean divided by the standard deviation. Now we are doing proportions, all right? So it's a little different. And then we use the test statistic to calculate the p-value. So when we're doing proportions, our formula is going to look a little different. So we still have a z-score for our test statistic. This time our statistic is p-hat. So it's what we got in our sample proportion. And we're subtracting our p null, which is the null hypothesis, so like that 80% in the free throw problem. And then we have our formula for the standard deviation for proportions. And this is on your yellow sheet. And so it's p times 1 minus p, and we use the p from the null hypothesis, divided by n, which is the number of trials. This is an important formula you definitely want to write down. So computing the test statistic in a simple random sample of 53 free throws, the virtual player made 32. So what we have is a proportion, and our p-hat is 32 out of 50. So when we watched, we got a statistic of 64%. But let's calculate the test statistic, which means the z-score. All right. So we're using our formula, the statistic minus the parameter divided by the standard deviation. And so the statistic is 0.64, what we got in our sample. The parameter is what we assume p is, that this guy's an 80% shooter. And we divide by the standard deviation, which is p from the null hypothesis, times 1 minus p, which is 20%, 1 minus 80, divided by n. N is the sample size of 50 free throws. Okay, plug that into your calculator, we get a z-score of negative 2.83. Okay, sketch a graph on these. We're talking z-scores, so just your chart that we did from chapter 2. And remember, it goes 0, 1, 2, 3, negative 1, negative 2, negative 3. So negative 2.83 and over. So how weird is it that our z-score is negative 2.83 or less, always shade a region. So because we have normality, we can actually use Normalcdf now that we converted it to a z-score, and we can check and get p-value. So norm CDF, and what's our lower bound going to be? Okay, negative 1,000. What's our upper bound going to be? Okay, negative 2.83. And our mean, we standardized this, so our mean is 0, and our standard deviation is 1. Okay, plug this in. Sorry, I ran out of room. We get a p-value of 0.0023. Okay, this is our p-value. In other words, this is the area under the curve. How weird is it? That's a pretty small number, right? So, find the p-value using table A or technology, show this result as an area under the normal curve, so we did that part as well. And let's interpret the p-value. So, anytime you're interpreting the p-value, if the null hypothesis is true, so if he's really an 80% shooter, there's only a 0.0023 chance that he made 32 out of 50 or less shots just by chance. All right, write down the name of this test. Okay, you're going to have to know all the different names. This one is called a one-sample z-test for proportions. So it's one sample because we only have one. In Chapter 10, we're going to compare two. And then z's always go with proportions. So we're going to start doing the four-step process: state, plan, do, conclude. So for state, you always want to state your hypothesis and the significance level and define your parameters. So write this down: hypothesis, significance level, and parameters. For the plan part, you're going to choose the appropriate inference method. That means you're going to actually write, I'm going to do a one-sample z-test for proportions. That's your inference method. And then in the plan, you need to check conditions. Is it random, 10% rule, and large counts? Okay. And then if those conditions are met, you can perform the calculations. You're going to have to find the test statistic, so in this case a z-score, and then find the p-value by Normalcdf. And then make your conclusion, right? So do we reject the null hypothesis or fail to reject the null hypothesis? Do we have convincing evidence? And always in context, okay? So there's your formula for a z-score for proportions. Okay, so we're computing the z-score. And just a graph to show you guys, if I'm doing an alternate hypothesis of greater than, then you should be shading to the right, and you should be getting a positive number here. And if I'm doing less than, you should be shading to the left. You should be getting a negative number here. And then you can also have your alternate hypothesis of just that it's different, that they're not equal. If that's the case, you have two tails, and you might want to remind yourself that if you have two tails, you will double your answer than if you had gotten one tail, all right? So you have a right or a left, and just make sure you times your p-value by 2, because you got to account for greater than and less than. So let's do an entire significance test. So the potato chip producer of section 9.1 has just received a truckload of potatoes from its main supplier. Recall that if the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. So the supervisor selects a sample of 500 potatoes from the truck, and inspection reveals that 47 of the potatoes have blemishes. So we already have a p-hat right here. And our p-hat is that 47 out of 500 have blemishes, which is 0.094. So we're going to do a significance test. They tell us at the 5% level, and then we need to figure out what to conclude. So we have our state. So we start with our hypothesis. So what do you think our null hypothesis is going to be? So we want to know, is it 8%? So our P would be equal to 0.08. Always use P here, not P hat. And then my alternate hypothesis would be, do I have more than 8% with blemishes? Because that would be a problem, okay? And we also need to define our P and state our significance level. So P is the actual proportion of potatoes with blemishes in the truckload, and then we're going to use our alpha equals 0.05. All right, now we have our plan. And so first for the plan, we have to state what kind of test we're doing. And so if conditions are met, we should use a 1 sample z-test for, for proportions. Okay, be sure you know the names of the tests. It'll also help you when we use our calculator. Then we need to check, is it random? So what does it say? Well, let's see. We have a random sample of 500 potatoes. All right, so random sample stated in the problem. Okay, then we need to check our 10% rule, which is n is less than or equal to a tenth of n. Well, we did 500. They don't actually tell us how many potatoes are in the truck. We just took 500 random sample. For this to be true, what would n have to be? N would have to be 5,000 or more. Is that reasonable to assume? Yes. All right. So you would write that down. It's reasonable to assume that there's 5,000 potatoes in the truckload. All right. And we also need to check large counts. All right. So here's our 10% rule. And now we got to check large counts. So large counts is n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So what is n? N is 500. P we always get from the null hypothesis, which is 8%, so 0.08. And we're going to do 500 times 1 minus 0.08, which is 0.92. And you guys make sure you actually calculate these. So we get 40 and we get 460. And so are these both greater than or equal to 10? Yes. All right, which means we have normality. All right, and then we got to calculate the test statistic. So show your work on this. We've got our z is equal to p hat. So p hat, we already calculated up here, is 0.094 minus p, which is the one we assume to be true, the 8%, divided by the standard deviation, which is 0.08 times 0.92, so p times 1 minus p, divided by n. N is 500 in this case. And we get a z-score of 1.15. All right, so then we calculate our p-value. Since we know it's normal, we can draw the normal curve. Whoops, a little crooked. 0, 1, so 1.1 something or other, and to the right. So I've got normal CDF. What's my lower bound going to be? 1.15. What's my upper bound going to be? 1,000 or 10,000. We standardized it. Mean of 0, standard deviation of 1. And we get a p-value of 0.1251. So our significance level is 5%. So is this number less than 5%? No. So when we write our conclusion, it always kind of looks the same, and you may want to write this down. Because our p-value, which is 0.1251, is greater than alpha of 5%, we fail to reject the null. So there is not convincing evidence that the shipment contains more than 8% blemished potatoes. As a result, the producer will use this truckload of potatoes to make potato chips. All right, we're going to also learn how to do this on the calculator. So one proportion z-test on the calculator. So go ahead and write this in your notes. You remember how to do it. You go to menu, statistics, stat test, one proportion z-test. And let's do the one that we just did. So everyone grab your calculators and do this with me. So go to menu, go to statistics, go to stat tests, and we're going one proportion z-test. So our null hypothesis in this one is 0.08, that 8% of the potatoes are blemished. We are going to plug in the number of successes from our trial that we did. So we got that 47 out of 500 were blemished. And our alternate hypothesis we want to put in this case we were seeing if there was a proportion greater than 8%. So if our proportion is greater than the null hypothesis, 8%. And we got a z-score of 1.15, that's what we got. A p-value of 0.1242, close to what we got. That's just due to rounding. Our p-hat, that's your 47 over 500, and our n is 500, which we got. Okay. So check it on your calculator. We will do this last one on the calculator and see if you guys can get it. So according to the National Campaign to Prevent Teen and Unplanned Pregnancy, 20% of teens aged 13 to 19 say they have electronically sent or posted sexually suggestive images of themselves. The counselor at a large high school worries that the actual figure might be higher than that. So to find out, she administers an anonymous survey to a random sample of 250 of the school's 2,800 students. All 250 respond, and 63 admit to sending or posting sexual images. Carry out a significance test at the 5% significance level. What conclusion should the counselor draw? So for the state, we got to do our null and our alternate hypothesis. So what do you guys think the null hypothesis is? It would be that p is 20%. Okay. And what do you think the alternate hypothesis is? We want to know, she's worried that it might be higher, so that p is greater than 20%. Make sure you define p and then state your significance level in the plan part. In the state part. Then we do plan. We're doing a one sample z-test for proportions. Is it a random sample? Yes. It says we have a random sample. 10%. So we got to check that 250 is less than a tenth of 2,800, which is true. 250 is less than 280. So that works. So we have independence. And then we have to check our n times p and n times 1 minus p. So n is 250. P is the proportion from the null, so 20%. And then you want to check 250 times 80% and make sure you get greater than or equal to 10, which we do. Okay, then we're going to do the calculation parts, and let's go ahead and plug this into our calculators. So go to menu, go to statistics, go to stat tests, go to one proportion z-test. Our null hypothesis is 20%, and then when they did the survey, they got 63 out of 250, and we want to know if it's greater than 20%. And we get our z-score, our p-value, and so if our p-value is 0.02, you guys, do we have convincing evidence that the alternate is true? And we do. All right, so when you do your conclusion, again, in context, because the p-value, which is 0.0197, is less than alpha, we reject the null. So we have convincing evidence that more than 20% of the teens in her school would say they have electronically sent or posted sexually suggestive images of themselves. All right, so here is your homework.